At this question, so we have right angle triangle. In the diagram, P is negative 15 is to Y, is a point on a Cartesian plane. OP is 17 units and reflects MOP is equals to alpha. 5.1.1. Determine the value of the following without using a calculator. So x squared plus y squared is equals to r squared. So our x is minus 15 squared plus y squared is equals to 17 squared. Therefore, our y is equals to square root of 17 squared minus 15 squared. So this must be a minus 8. So this is minus 15 and that's a minus 8. 5.1.2. Sine 90 plus alpha. So this is 90 degrees plus alpha. 90 plus is in the second quadrant. In the second quadrant, sine is positive. But because we are using a 90, the sign will change into a cos. So cos by definition is x over r. 5.1.3. They want us to find tan beta if alpha plus beta is equal to 540. So this is alpha plus beta, which is equals to 540 degrees. So I'm just gonna transpose the 540 to the other side. And then I'm going to introduce tan beta both sides. I'm going to introduce tan both sides. So I'll have tan alpha and then we'll have tan 540 minus beta. Whenever we have an angle that's greater than 360, we'll subtract 360 from that angle. Here I'll be left with tan alpha is equals to tan 180 minus beta. So I subtracted I subtracted 360 from the 540. So I know that tan of alpha is given by minus 8 over minus 15. And then 180 minus is in the second quadrant. In the second quadrant, tan is negative beta. So this means that my tan of beta should be equals to 8 over 15. This negative takes care of that one, so I'll be left with this one. So it is minus 15. 5.2. Sine 180 degrees minus x minus 2 cos of 90 degrees minus x times cos of x. All of this divided by 2 cos squared 360 plus x minus cos minus x. 180 minus is in the second quadrant. In the second quadrant, sign is positive, minus 2. 90 minus is in the first quadrant. Cos is positive there. But because I've used a 90, this will change into a sign. $360 plus is in the first quadrant. Cos is positive there. So this is 360 minus x, which is in the fourth quadrant. In the fourth quadrant, cos is positive. So I'm going to take out a common factor of x. So this is 1 minus 2 cos x. Okay, so this, I'm going to take out a factor of cos of x. So I'll be left with 2 cos x minus 1. Okay, so you'll notice that these two are not the same. So what I need to do first is to take out a factor of a negative. So I'm going to take out a factor of a negative there. So this is a negative, and then that's cos of x minus, so that when I say negative times negative, I get the 2 cos squared x. So this is 2 cos squared x. And then now I'm just going to fix this. So this is 1 minus 2 cos of x all over that negative. Then I'm going to fix what's inside. So I'm going to take out a factor of cos of x. So this is 1 minus 2 cos x. So now these two, they are the same. So I am left with negative sine of x over cos of x. So this is minus tan of x. 5.3.1. So I need to prove the identity. Like on the right hand side, there isn't much to do, so I'm going to pick the left hand side. So this is 1 minus tan x. Of course, you'd say the left hand side is equals to, yeah. And then this is 1 plus tan of x. 1 minus tan is sine x over cos of x divided by 1 plus sine of x over cos of x. And then now I'm just going to say 1 times cos of x. This is going to be cos of x minus sine of x all over cos of x. This is for the numerator. Now I'm fixing the denominator. This is cos of x plus sine of x all over cos of x. Okay, so this is cos of x minus sine of x all over cos of x. So this is divided by the whole of that. So I want to change the division sign into a multiplication. So I'm just going to swap those around. So this is going to be cos of x, and this is going to be cos of x plus sine of x. So this takes care of that. So I am left with, just going to put brackets there. So I am left with cos of x minus sine of x all over cos of x plus sine of x, which is equals to the right hand side. 5.3.2. For which values of x in the interval is the identity in question 5.31 undefined? So for something to be undefined, the numerator you'll have a number, and then in the denominator you will have a number that is equals to 0. So if the denominator is equals to 0, the thing is undefined. So let's just try and take both. So for the left hand side, 1 plus tan of x should be equals to 0, because we want the denominator to be equals to 0. And then this is tan of x, which is equals to negative 1. So the angle there, tan of negative 1, so I'm getting negative 45 degrees. This is equals to negative. Okay. However, but the restriction that I'm given, they said that x must be between 180 degrees and 0. So the period of a tan graph is 180 degrees. So if I want to know the point in which tan of x is going to be equal to negative 1 again, I just need to add 180 on top of what I've already gotten there. So this is going to be x is equals to negative 45 degrees plus 180. So I'm going to get 135 degrees. This is going to be the x value. Let's try the right hand side. So cos of x, you needn't do both of these, just use one side. to find the value of x, and that's it. Plus sine of x is equals to 0. So it means that cos of x is equals to negative sine of x. And then now we're just going to draw the graphs. So this is 90, 180, 270, and 360. But we only need this portion right here, only up to 180. So the graph of cos goes between 1 and negative 1. And it starts at the top. So it goes like, that's what I'll have. That is the graph of cos. And then the graph of sine, so it's negative sine. So it's going to start at 0 and then it will go down. So it will look like that. That will be the graph of sine. So as you can see, these two, they meet somewhere around there. Then you can just use your calculator. You'll say mode setup, the table, and then you say cos of x, then negative sine of x for the other graph. Then you say start at 0, end at 180. So the steps should be 45. And then you will see that when you get to 135, the values are exactly the same. So the x value there should be equals to 135 degrees. Then 5.4, the general solution. This is 2 tan of x, which is equals to 5 sine x. So this is 2 sine x over cos of x is equals to 5 sine x. Then this is 2 sine x, which is equals to 5 sine x cos of x. And then we do not cancel out. We don't do this when we are dealing with general solutions. You will lose one solution. So instead, you transpose 5 sine x cos of x minus 2 sine x is equals to 0. Then we take out a factor of sine x. This is 5 cos of x minus 2 is equals to 0. So sine of x should be equals to 0, or cos of x should be equals to 2 over 5. So the reference angle there should be equals to arc cos 2 over 5. So I am getting 66.42 degrees. And we are working in the quadrants where cos is positive. The reference angle on this side should be equals to 0. So this is 0 degrees. And then we are working in the quadrants where sine is positive. So this is quadrant 1 and quadrant 2. And then for the side, it's quadrant 1 and quadrant 4. So x should be equals to 0 degrees plus k 360, where k is an element of integers. And then in the second quadrant, this is going to be 180 degrees minus 0 plus k 360 degrees. So this is 180 degrees plus k 360. This side, in the first quadrant, x is going to be equals to 66.42 degrees plus k 360 degrees. In the fourth quadrant, x is equals to 360 degrees minus 66.42 plus k 360 degrees. So this is x is equals to 360 minus 66.42. I am getting 293.58 degrees plus k 360 degrees.